Okay, section 3, we're covering the third method of solving systems. And this one is either called the addition method, the elimination method, or linear combination. And any one of these names should make sense here in just a bit. Let's see what we've got. Okay, let's say you had this system you see. No way would I want to graph that, right? If I had to cover up x and solve for y, I'd get a fraction. If I covered up y and solved for x, I'd be okay. On the bottom one, fraction, fraction. Yeah, I wouldn't want to do that. Okay, would I want to do substitution? Is there any variable that's easy to solve for? Maybe x right there, right? Because if I divided by 3, I'd get a fraction slope. But in general, it's not a nice one to do in the two methods that we already know. So graphing is easy if both equations are in standard form and they have easy intercepts. That's like covering one and solving for the other. Or if they're both in slope-intercept form with nice values, so like your y-intercept is not a fraction. Substitution's easy when you have one variable that's solo, so there's no coefficient and it's easy to solve for. But if you don't have any of these things, like this method works really well. Okay, here's a list of steps, and they're not going to make sense right now because you haven't seen a problem yet. So I'll come back to these, but I'm going to show you on this next example. Okay, mine's actually harder than yours, so you can see all of my coefficients and you don't have any, so yours should be easier. You do have this one, which has not nice answers, but let's take a look at how you do this method, okay? Now we're going to start out with some that are set up to work easier. This is one of them. Okay, so the addition elimination method or linear combination. So what you're going to do is literally add the two equations once you get them in the right format. And while doing that, one variable will be eliminated. Okay, let me show you. This one is set up so that it's going to work. We're going to add the two equations together. And notice that the 5y's cancel out. Okay, it was set up to have this happen. Sometimes you're going to have to make it happen, and I'll show you how to do that. So now add straight down. We get 12x, the y's are gone, equals 36, which is now one equation with one variable. And we're going to solve for x. So we end up with x equals 3. Okay, so addition because we added the two equations together, and elimination because in the process of doing that, one of the variables was eliminated, so we can solve for the other one. Okay, now that we've got the other one, we're going to do like we did in substitution and plug it back into any equation with both variables. Okay, so it could be this top one or the bottom one. And I'm going to choose the bottom one because the numbers are smaller. Okay, so remember how in the last video I called this A and this B? So you can figure out what I'm doing. Okay, I am going to substitute that value into B. But I am going to do it up higher so I have enough space. Okay, so B is 4 times whatever x is, add 5y equals 4. X we just found was 3. So 12 add 5y equals 4. Let's minus 12 from both sides. And we get 5y equals -8. Divide by 5, and we get y equals -8/5. Okay, now that seems like a very strange answer, but I guarantee that it is correct because I double checked it in each equation, but let me show you. Okay, that red part shows both substitutions and they are both true. So that is my correct answer. Okay, but the process, now that you've seen one, let's go back to that first page or the one just before this and show. Okay, so first thing is get both equations in standard form. The one that we had was they were already given to us in standard form, so we didn't need to do that. Multiply one or the other, we didn't need to do that. We're going to do that next. Add the two equations. Solve the resulting equation for the variable. Substitute it into the other or into either equation with both variables. Solve the new equation and write it as a point. Okay, so solve, substitute, solve, point are the same steps that we did in substitute. So these first few are a little bit different, and that's all. Okay, so with that in mind, you're not going to have to do the one step that says multiply both sides. So see what you can do with your two. Okay, these are already in standard form, so we're going to check and see if when we add them together, does something eliminate? And it does. Okay, so if I add them right now, these two combine together, but these two are eliminated. Okay, so here we go. Let's do it. Add these up. We end up with 2x, y's cancel, equals 20. Divide by 2, so x equals 10. Okay, now I'm going to choose either equation and substitute x equals 10. Again, I'm going to choose the bottom one because it has smaller numbers. And actually, I'm just going to rewrite it over here. I didn't do that last time. X is 10 plus y equals 2. Minus 10 from both sides, and we get y equals -8. Okay, so the point would be x comma y. And if you're wondering whether it's the correct answer or not, you could just plug them into both equations, but do it in your head. Okay, I'm going to actually write it down. Okay, so this is equation A, equation B. A is x minus y. Is that equal to 18? And B is x add y. Is that equal to 2? And two negatives make a positive. 10 plus 8 is 18, so that one's true. Positive 10 plus -8 is also true. Okay, so that is correct. Okay, let's take a look at your second one. And once again, it's set up to work. So you got lucky in this one. Right now, if I add, these two will eliminate. These two combine with those. Okay, so let's add. Those cancel because they are opposite coefficients, right? So -4, +4 would give you 0x. So it eliminates. So now add the y's and we get -5. Add the answers and we get -3. So this is what they mean that you won't always get nice answers. In fact, we're going to get a fraction. So y equals +3/5. At this point, I would be double checking to make certain that I didn't do anything stupid and this was really the wrong part. Anytime you get fractions, you kind of worry, huh? Okay, so now I need to substitute it into either equation with both variables. I'm going to choose the easy one. Seems like these have smaller numbers and I don't have negatives, so I'm going to use the bottom one. Okay, and organizing just a little bit differently, I'm going to do it right below. Okay, 2y equals 3. So x is going to stay, but I'm going to replace y with 3/5. All right, now that fraction, we can't do anything. You put the 2 over a 1, and we're going to multiply straight across the top and get 6, across the bottom and get 5. So we get 6/5 equals 3. Okay, now you have a few options. You could deal with the fractions or you could get rid of them. Personally, I'm going to get rid of them. Okay, so I'm going to times everything by 5. This is what we learned how to do in chapter 1. So now we get 20x add 6 equals 15. Much easier for me to work without fractions and have to do some computations off to the side and all that. So 20x equals 9 divide by 20. So x equals 9/20. Wow. Okay, alphabetical order, 9/20, comma, 3/5. Can you imagine finding that answer by graphing? You know, that's just ridiculous. Okay, let me double check. Okay, so here's substituted into A. 4 and 20 both divide by 4. So I end up with negative 9/5 minus, nothing cancels there, so I get 21/5. Is that equal to negative 6? I don't know yet. One more step. Let's combine these two. So negative 9 minus 21 is negative 30 over 5. And yes, it does equal negative 6. So that one is true. And there it is substituted into B. And once again, the 4 and the 20 cancel because they both divide by 4. So I end up with 9 over 5 plus, nothing cancels here, so I get 6 over 5. Does that equal 3? Yes, it does, but let's go one more step. So we're going to do 9 add 6, because they already have the same denominator, right? So 9 add 6 is 15 over 5, which does divide to 3. So that also checks. And this is the correct answer. Okay, so everything that we've learned up to this point is going to be needed sometimes. Solving with fractions and doing all that kind of stuff. Okay, now step 2, or question 2, is going to need step 2. Okay, so step 2 says multiply one or both equations by whatever it takes to get opposite coefficients for one variable. Bleh, right? Okay, so on this particular one here, opposite coefficients for one variable is exactly what we had right here. The variable was y, coefficients were negative 5, positive 5. Those are opposites. Over here, y. This was a negative 1 and a positive 1, which were opposites. Here's your 1b, variable x. The coefficients are 4 and negative 4, opposites. Okay, so here we don't see that, do we? Okay, so let's do the example number 2. All right, what we're going to do on this one is multiply either one or both rows by whatever it takes. What I look for is one that is already positive and negative and see if that works. And in this case, it does, because this is a 1y. I can multiply 1 by anything and get the opposite of whatever this is. Okay, so I'm going to times the second row, the entire row, by 2. Okay, so basically I'm doing this with the 2. Okay, I'm not going to leave them there because that's a total mess, but that's what I'm doing. Okay, so I'm going to rewrite the entire thing. Okay, remember we talked about should have the little brace thing here keeping it together. I'm going to keep it together. So the first equation, I'm going to rewrite it. And the second equation, I'm going to rewrite it, but multiplied by 2. So now I get 6x minus 2y equals 12. And this is still my set of equations that make up my system. Okay, so now I can add them up. If I add these up, the y terms are eliminated. They cancel. What do I have left? So I have 14x equals 14. They were being nice in this one. So divide by 14 and I get x equals 1. Okay, now I need to substitute it into any equation with both variables. So I have the two original ones, or I have the blue one I could use. I don't use these too often because the numbers got bigger, right? I'm going to choose this original second one. So again, I'm going to label them for you so you can see what I'm doing. Okay, I'm going to substitute it into b. So b is 3x minus y equals 6. And x is now 1. And I can solve for y. Okay, now this one, I do have that negative I have to deal with. So maybe substituting it into the other one would have been better. Totally your choice, whichever one you want. The reason it works is because the answer to a system is where the two graphs cross, right? So the point is going to be on both graphs. So you can choose either one and it will be on it, okay? So I got y equals negative 3, and my point in alphabetical order is 1, negative 3, okay? Double checking. Okay, again, you can do this in your head, and I would, just to get used to double checking if you don't want to write it down. Okay, so this gives us 8 plus negative 6, which does equal 2. That works. Okay, and 3 times 1 minus negative 3. Does that equal 6? Change here, and I do get 3, add 3, which equals 6. Yes. Okay, is the substitution, that red part, necessary? No. Is it helpful? Absolutely. All right, so go ahead and try yours. You're going to have to multiply by something to get one of the variables to cancel since it's not ready to go right now. So like we did for substitution, if you look for a solo variable, so in this case, this x, because there's no coefficient, that's what makes it solo, right? You can times this whole equation by whatever it takes to get it to cancel with the other equation right here very easily. Okay, so I'm going to times this equation here by negative 3. You can put it at the front, you can put it at the back, you can put it wherever you want to. But when I end up doing that, I'll have a negative 3x right there, and these two will cancel, right? Okay, so let's multiply it. Here we go. So the first equation becomes negative 3x add 9y, negative times a negative, right? Negative times negative is again positive, 21. And the second equation is just going to come down. And now you're going to add these two together. That makes the 3x's cancel, and we end up with 11y equals 44, which works out really nicely. So y equals 4. Okay, substitute that value back into one equation, and I'm going to choose A. Would I get the same answer if I put it in B? Absolutely. I just choose the easiest one for me. So if the second one looks easier to you, then you use it. Okay. I like choosing smaller numbers, whether they're positive or negative. But if you like using positives, then do that, you know. Now we're going to add 12 to both sides. So I get x equals 5. Okay, now so far, the red part that I've been doing for you, I've just written out the entire thing. Okay, another way of doing that is taking your values and plugging them in like this. Okay, so x is 5, and then minus 3 times y, so 3 times 4 is 12, and that is negative 7, right? So that works. 3 times x, or 3 times 5, is 15. Add 2 times y, which is 8. Add those together, you get 23, and that works. So you just do whatever it takes so you can double check yourself. Okay, and there's my solution. Don't forget to write it as a point. Okay, and now let's get one step harder. Okay, remember how I said to look for a solo variable? There isn't one. Okay, so what we need to do in this particular case is, I keep hitting the wrong button, and why I tell you that, I don't know. Okay, what we need to do is times both equations by something. Okay, what and how do I figure this out? Doesn't matter. You can choose to eliminate x, or you can choose to eliminate y. It doesn't matter. Again, I choose the smaller numbers, so I'm going to choose 5 and 6 because they're smaller than 7 and 8. So what I'm going to do is times both rows by whatever it takes. Let's see, let's do two different colors. Yeah. So I'm going to times the top row by 5. This isn't quite right yet, and the bottom row by 6. And if I did that, then I'd have a 30 and a 30. I need them to be opposites, don't I? So that means one of them needs to be negative. This is positive 30. Now this is negative 30, and something will actually eliminate when I add. Okay, so let's see what I have. I'm going to rewrite these. 5 times everything. So now I'm doing this and this. But again, I'm not going to write that. And I get 30x add 35y equals 20. Second equation becomes negative 30x minus 48y equals 6. And now this becomes my new system. Right now, I can add those instantly because of what I chose to multiply by, and the x's are eliminated. So now I get negative 13y equals 26. Okay, divide by negative 13. So I get y equals negative 2. Now I'm going to substitute it into an equation with both variables. So I have first one and the second one of the original, and my blue one and my red one. These numbers are just way too big, so I'm going to use one of the top ones. Okay, this bottom one has a negative in it, so maybe I want to avoid that. So let's do the blue one. Okay, so equation A, equation B, we're going to substitute it into A. So A is 6x add 7y equals 4. So stick in my x value. Whoops, I don't have an x value yet. I'm solving for x, right? So substitute in my y value. And now I'm going to solve for x. So 6x minus 14 equals 4. Then I want to add 14 to both sides. So 6x, 14's cancel, equals 18. Divide by 6, and I get x equals 3. And a quick double check. So I'm going to put x in, so 6 times 3, and I'm going to put y in and see if it's equal. So 18 minus 14 equals 4. Yep. Put in x and y and see if I get negative 1. And I made a mistake, didn't I? I put y in incorrectly. So it's negative 2 equals negative 1. So I have 15 minus 16 is negative 1. Yep. Which means my point in alphabetical order is 3, negative 2. Make certain you have it in point format so it needs parentheses. Okay, so the only difference is you're going to times both equations by a number this time instead of just one. And go ahead and try yours. See what you can do. Okay, personally, I'm going to eliminate y. And the reason for that is they're already opposites. Okay, so I'm going to times the top equation by 2 and the bottom equation by 5. So that way I have a negative 10 and a positive 10. Okay, the other option would be to times the top one by 3, bottom one by 4 to get 12 x's, but then you'd have to make one of them negative, either the 3 or the 4, in order to have a positive 12 and a negative 12. So that's why I choose the opposite signs to begin with. Okay, so once I multiply those through, I have 8x minus 10y equals negative 36, and 15x add 10y equals negative 10. So that's my new system, and I'm going to add it up. Okay, so hopefully you have been nice and neat and organized. And remember, I told you once that you can't make up your own way of doing things. Please don't. Okay, and also please be organized because if you don't know where you're going next, you're going to confuse yourself. And if you get the wrong answer, I'm not going to be able to see what you did to be able to give you part credit if I can't figure out your order of things, you know? Okay, so x is equal to negative 2 for this one. So now I'm going to substitute it into any equation. I'm going to substitute, well, any equation with both variables, right? I'm going to put it into b. So I'm going to do 3 times whatever x is plus 2y equals negative 2, and x is negative 2. So negative 6 add 2y equals negative 2. Add 6 to both sides, and I get 2y equals 4. Divide by 2, so y equals 2. Now, if you would have eliminated the x's instead of the y's, you're going to get the same answers, but you'd get them in the backwards order. You would find y first, and then when you plugged y back in, you would find x. But you'd still get x equals negative 2 and y equals 2. And there's the corrections, or the double check in orange. So it does work. And I'm going to write it as a point, negative 2, positive 2, and there we go. Okay, so the trick to these is you have to multiply both equations by something, right? All right, let's see what we have next. All right, these two, um, we haven't seen our special cases yet, have we? Let's see what these are. All right, first of all, we have two equations, A and B, and I do have a solo variable. So I'm going to times this top row by negative 3 to get y to cancel. All right, so I end up with okay, here's the one on your side. See what you can do with it. Okay, I'm going to have to times both equations by something, right? Okay, one thing that you can do is times them by each other. So I could times the 2 by the 5 and the 5 by the 2. Or I'd times 4 by 10 and 10 by 4. I'd get 40 here, or I'd get 10 here. I'm going to choose to do the x's because I don't want bigger numbers if I don't have to. Okay, so if I times them by these particular numbers, I'll get a negative 10 and a positive 10, right? Okay, so the blue one becomes negative 10x minus 20y equals negative 5. And the red one becomes 10x plus 20y equals 30. Okay, so when I add these up, we get a 0 for x, 0 for y, but we get 25 on the other side. This is false. Okay, so both variables cancel, and what we have left is false. So that means, yeah, you won't have an answer because the lines are parallel. Okay, so this one is either D and E. The answer does not exist. It's no solution. It's not possible. Something. Okay, they are parallel lines. They will never cross, so you will never get an answer. Okay, so the green part is the same no matter what, right? If you get something that's true, you're going to have answers. If you get something that's false, you won't have any. Okay, and when it's true, you're going to have a lot of answers, an infinite number of them, but you have to write it correctly. Okay, so if you have something like this, where it just looks crazy, let's try to get them into a format that's not so crazy. In other words, get rid of the fractions and see what's happening. Okay, so if that's the case, I'm going to times by 3 and 2, right? Or 6, if you want to just do 6. 3's cancel, 2's cancel, nothing cancels. So the new top equation is going to be 4x add 3y equals 36. The bottom one's going to stay the same. And now we got lucky because these two have opposite coefficients already. So now all we have to do is add it up. Okay, so add these. We end up with 6x, those cancel, equals 36. Divide by 6 to figure out what x is, and we get x equals 6. Okay, substitute it into an equation with both variables. I would not use the first one with the fractions. Well, you could if you're okay with that, but I would just choose not to, you know. Second one looks like it might be pretty easy, especially with the 0. But now we have this option as well. These numbers are much bigger, so I'm not going to worry about that one. I'm just going to put it into B. So here's A, here's B. I'm going to put it into B. So I get 2x minus 3y equals 0. However, x is 6. So 12 minus 3y equals 0. Minus 12 from both sides. So negative 3y equals negative 12. Divide by negative 3, and y equals 4. And there's the work for checking it, so you can see that it works. Okay, for the last problem, of course it's going to be the hardest one, right? Yeah, neither one of these are in any format we recognize. So most likely, got to get rid of the parentheses. Okay, in fact, we absolutely have to because there are no parentheses in standard form. So let's do that to begin with. So here is A. I'm going to distribute the 4. And on B, I'm going to distribute the negative 4. And I'm going to write the new set over on this side. Okay, so it's going to go this way. So 4 times 3/4. Remember, you put the 4 over a 1, and we're going to cancel the 4's. So we get 3 over 1, which is 3. So that becomes 3x add, this one is 4y, and it's just going to equal 4 because I didn't do anything to this side. Okay, on B, I'm going to go negative 4 times 4x. Try it again. Negative 4 times x is negative 4x. Now negative 4 times 13/4. So negative 4 times 13/4. Whole numbers get put over a 1, and now those cancel. So I get negative 13 over 1, which is just negative 13. So that comes up here, and that's equal to negative 2y. Okay, now these two things are in the wrong place. That should be x, y, no variable. So I got to change these. Okay, I'm going to add 13 to both sides. So these cancel. I end up with negative 4x equals negative 2y, add 13, add 2y to both sides, and I end up with negative 4x add 2y equals 13. Okay, so this red equation is going to replace this red equation with this blue one and become our new system. Okay, so that becomes this. 3x add 4y equals 4. And this one's going to go up there now, right? Negative 4x add 2y equals 13. Okay, now that we have the system in standard form, now we can think about what we're going to do with it. Okay, so looking here, we want to attempt to either eliminate the x's or the y's. If I do the x's, I times the top by 4 and the bottom by 3 because I get a 12x and a negative 12x. If I did the y's, because 2 goes into 4, I could times the bottom row by negative 2, and I could leave the top row alone. So that's the shorter version. That's what I'm going to do. Okay, so I'm going to times the bottom row by negative 2. And I am going to rewrite it all the way over here. Okay, and I'm trying to keep it on one screen for you so you can visually see everything. Normally, I would just keep going down the page, but I went across, because I knew I had some stuff to show you. Okay, so here we go. Final system before we eliminate. So 3x add 4y equals 4. Now timesing by negative 2, I get positive 8x minus 4y equals negative 26. And now add. The 4y's cancel. I get 11x equals negative 22. And that works out really nicely. Okay, halfway there. Actually, we're way more than halfway there because I had to do all of this already. Okay, substituting x into any equation with x and y, I would not use the originals because those are crazy. So we have the blue one, which is the top one simplified. or we have this red one or this red one. Okay, if I'm substituting x, this one might be the easiest because we're already almost solved for y. Okay, so that's the one I'm going to choose right there. Okay, so as long as you've done your math right, which I'm pretty certain we have, then any of the equations that you've created will give the exact same answer. Okay, so x is -2, and then minus 13 equals -2y. So negative times a negative is a positive. Almost blew that one. -2y. So I get -5 is equal to -2y. Divide by -2, and we get y equals positive 5/2. So that looks kind of strange. I'm going to check into both equations. Okay, now when you check, you need to check it in the original. Okay, so here's equation A. Now it gets kind of complicated because I put parentheses around x like I normally do when I substitute it, but there were already parentheses in my problem. So I got to be really careful. If you want to rewrite the second set of parentheses as brackets so that you don't get confused, that's absolutely fine. Okay, let's keep going here. We're checking. All right, so the 4 stays. 4 and 2 both divide by 2, so I get a 1 and a 2. So -3/2 plus 5/2. And I want to see if it equals 4. Okay, so 4 times 2/2. Does that equal 4? 2/2 is 1. 4 times 1 is 4. Yep, that one's true. And I thought I had the colors figured out, but yeah, ignore the colors. Okay, this one right here in the middle is kind of crazy. So I'm going to rewrite the -2 as fourths. So I'm going to rewrite that as 8/4 to make it the -2 that I started with, right? Okay, so now I get -4 on the outside. On the inside, I have 5/4. So the 4's cancel. And over here, the 2's cancel. So I get -5 on this side, and I have -5 on this side. So that is also true. My answer then is -2, 5/2. Kind of crazy. And that was a definitely the hardest problem we've seen. Alrighty, guys, you can do this. Don't assume that they're all going to be this hard. They will most likely be closer to like this one, or even, when you just have to add straight down because they're already set for you. Okay? Alrighty. Good luck. You got this.